Okay, our seventh unit is the computer arithmetic. So these are all the topics: binary arithmetic, number system, binary, octal, decimal, hexadecimal. These are the number system. And then the last point is the converting from one number system to another. Okay. So what is the binary arithmetic? Basically, binary is the base two number system that uses two values. First one is the 0 and the second one is the 1. Okay. So the base of the binary arithmetic is the 2. 2 is the base number of the binary arithmetic. To represent a number, we can also call it true for 1 and false state for the 0. A binary number is made the same way as we form normal decimal number. Binary arithmetic is very important part of various decimal system. Using various methods, we can perform addition, subtraction, multiplication, and division in binary numbers. So similarly, we do in the decimal number system, we can also do the same multiplication, addition, division in the binary arithmetic system. And what is the numeral number system? Basically, numeral system or number system. So numeral system in computer science refers to the numeric base system used for the performing computation, storing and representation data. The most common of these are the binary. The base of the binary is 2. The second number system is the decimal, that is the base 10. And the third one is the octal number system. The base of the octal number system is the 8. And the hexadecimal, that is the fourth number system. So hexadecimal base is the 16. Okay, so these are the basic number system which is used in the computing or programming. So basically, we have to convert these number system from one number system to another, and also perform the some arithmetic operations like addition, subtraction, multiplication, and division. Now, okay, the first thing is, what is the binary number system, decimal number system, octal, and hexadecimal? Okay, so binary means 0 and 1. Decimal, that means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Okay, similarly, octal number system, that means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Basically, the number system which belongs to the base of 8. Okay. Now, similarly, the hexadecimal number, that means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But in this case, the 10 will be represented as a alphabetical form A. Now, the 11 will be represented as B. And similarly, 12 will be C. And 13 will be represented as a D. Okay, so A is 10, 11, 12, 13, 14 will be E, and F is the 15. So this is the representation of hexadecimal number. Always remember, in hexadecimal number system, the 10 represented as a, 11 as a B, 12 as a C, and 13 as a D, and 14 as a E, and 15 represent as a F. Okay. Now, okay, some basic arithmetical operation or rules for addition and subtraction for in the binary number system. So the next thing is binary arithmetic. Okay, the binary arithmetic means we can do the addition, subtraction, multiplication, and division in the binary form. That means in the 0 and 1 form. So the first thing is the addition or binary addition. Okay, so always remember, in this number system, we use just 0 and 1 as a number system, and the base will be 2. So if you want to add 0 plus 0, it will be 0. Okay, Similarly, if you want to add 1 plus 0, it will be 1. Similarly, 0 plus 1, it will be 1. And if you want to add the 1 plus 1, so always remember it's not will be the 2, it will be 10. Okay, so always 1 plus 1 will be 10. 1 0, that means it's not 10, basically it's a 1 and 0. So this 1 will be the carry for the next column. Okay, so always remember the 1 plus 1 will be 1 0 and 1 will be carried to the next column or the second right of the column. For example, if you want to add 0 plus 1, it will be 1. Okay, and if you want to add 1 plus 1, the addition will be 1 0. Okay, again if you want to add one more in this 1 0, so it will be 1 and 1, because 0 plus 1 will be 1 and 1 as it is, then it will be 1 1, that is the 1 1. Okay, now if you want to add one more in this one, so it will be 1 plus 1. So 1 plus 1 will be 0, because it's a 1 0, so 1 will be carry for the next column. Now 1 plus 1, it will be again 1 0. So the addition of 1 1 plus 1, it will be 1 0 0. Okay, now again if you want to add 1 0 0 plus 1, so it will be 1 0 1. It's a 1 0 and 1. One more, add one more 1. So 1 plus 1, it will be 0. Carry will be here, and then it will be 1, and it's again 1. So 1 1 0 is the addition of 1 0 1 plus 1. Okay, similarly, if you add 1 in 1 1 0 plus 1, so it will be 1 plus 1 plus 1. Okay, then if you want to add one more, 1 1 1 plus 1, then it will be 1 plus 1, it's 0, and the carry is here. Now 1 plus 1, it will be again 1 0, so 0 is here and carry is there. Now 1 plus 1, it will be 1 0. So the addition of 1 1 1 plus 1 will be 1 0 0 0. So this is the basic procedure of to adding the binary numbers, that is the 0 and 1 numbers. So the always remember it's always doing in the form of the 0 and 1. Okay, now let's see some examples of addition. Okay, the first example is, suppose we have number 1 1 and 1, and the second number is the plus 1 0 and 1. Okay, so the answer will be 1 plus 1, it will be 0. The carry is in the next column. Again 1 plus 1, it will be again 1 0. So 0 is here, and the carry will be in the next column. Now 1 plus 1, it will be 1 plus 1, that is the 1 0. And now 1 0 plus 1, it will be 1 1. So the answer will be 1 1 0 0. Okay, 1 plus 1, it will become the 1 0, and 1 0 plus 1, 1 0 plus 1, it's a 1 1. So the answer will be 1 0 1 1 0 0. Is that clear? Now the second example, suppose we have 1 1 1 and again 1 1 1. Now 1 plus 1, it will become 1 0. So 0 is here. Now the carry in the next column. So 1 plus 1, it's a become 1 plus 1, that is 1 0. And 1 0 plus 1, it's a 1 1. So 1 is here, and again the carry will be in the next column. Again 1 plus 1, it's a 1 0, and 1 0 plus 1, that is 1 1. So answer will be 1 plus 1 1 1 0. Example number 3 is 1 1 1 1 1. Again, okay, all ones, 1 1 1 and 1. Now 1 plus 1, it becomes 1 0. So 0 is here, carry will be in the next column. So 1 plus 1, it's a 1 0, and 1 0 plus 1 1 1. So again it's a 1, and the again 1 carry in the next column. So 1 plus 1, it will become 1 0, and 1 0 plus 1 1 1. So 1, and again carry 1 plus 1 1 0 plus 1 1 1. So 1 and 1 is the last carry in the last column or leftmost column. Okay, 1 plus 1, it's a 1 0, and 1 0 plus 1, it's become 1 1. Now the answer will be 1 1 1 1 1 0. It's the final answer. Okay, 1 0 1 0 and 1 0 0 0, and suppose the next is the 1 0 1 0 1. Okay, now 0 plus 0 0, 0 plus 1, it's become 1. Okay, so 1. So there is no carry. Now 1 plus 0, that means again 1. 0 plus 0, it's a 0. Then 0 plus 1, it's again 1. Now 1 plus 1, it will become 1 0. So the final 1 0 1 1 1 is the answer. Okay, the next thing is subtraction or binary subtraction. Okay, the rules of the subtraction is 0 minus 0, it will become 0, obviously. Now 1 minus 0, it's a 1. And suppose 1 minus 1, it will become 0. And similarly 0 minus 1, it will become 1 if with a borrow from the previous column. So basically there is a condition of borrowing from the next column. So if you borrowing from neighborhood column or previous column, then it's become 1. Like for example, suppose the first example is 1 0 and 0 and minus 0 0 1. Okay, now if you 0 minus 1, so 0 minus 1, it will become 1 if you carry from the previous column. So the previous column is already 0, then we have to borrowing from the next previous column, that is the 1. So 1 is borrowing from here, and then borrowing from the previous column. So it will become 1 0. Okay, always remember this is big, it will become the 1 0. Now if minus 1 0 1 0, so it's become 1. Okay, because if you 1 plus 1, it will become 1 0. So similarly, if you minus or subtract 1 from the 1 0, it will become 1. That's why it's become 1 0. So minus 1 0 minus 1, it will become 1. Okay. Now this is the second column, and the second column will obviously it will become 1, because it's if the borrowing from the previous column, it will become 10, and again it's borrowing from the second column, give the 1 number to the last column. So that's why it remaining portion is the just 1. So 1 minus 0, it will become 1, and the last one is already 0. So because the previous the next column is the given by this column, so that's why it's become 0. So 0 minus 0, it will become 0. So answer will be 0 1 1. Okay. Okay, the next example is, suppose 1 0 0 and 1 minus 0 1 1 and 0. Okay, so 1 minus 0, it will be 1. Okay, now this is 0, so 0 minus 1, it's not possible. Then we have to need the borrowing from the previous column. So this is the previous column which is already 0, so we have to move the leftmost column, so we can borrowing from this column to this, then next column, so it will become 1 0 and it will become 1. Okay, so 10 minus 1, it will become 1. Correct. Now 1 minus 1, it's a 0, and 0 minus 0, it's again 0. So answer again 0 0 1 1 is the final answer. Okay, the next example is suppose, okay, last example repeat to nahi hua na. Okay, repeat to nahi hua hai. So okay, third example is 1 0 1 0 1 and minus 1 0 0 1 and 1. Now 1 minus 1, it will become 0. Again borrowing from the next column to this column, so it will become 10, and 10 minus 1, it's a 1. This will become 0, so 0 minus 0 0, 0 minus 0, it will become 0, and 1 minus 1, again it will be 0. So answer will be 0 0 0 1 0. Example number 4 is like 1 0 0 0 and 0, then minus 0 1 1, again 1 and 1. Now 0, we have to borrowing from the next column or previous column. So basically we have to need the last borrowing from the last column, so it will become 10. Now again it's give the one number, so next column from here to here. Now it will become 10, so 10 minus 1, it will become 1. Okay, 10 minus 1, it will become 1. Now it's a 1, so 1 minus 1, it will become 0. Is it clear? Again this is 1, so 1 minus 1 0. This is 1, 1 minus 1, okay, 0 na 0, 1 minus 1, it's 0. Now this will become 0 na, so 0 minus 0, it will become 0. So answer will be 0 0 0 1. Okay, similarly 1 1 1 and 0, suppose 0 0 1 1. So 0 minus 1, it's not possible, so that's why we have to borrowing from the previous column, so it will become 10. 10 minus 1, it will 1. Now it will become the 0, so we have to borrowing from the previous column, so 1 and 0, so it will become 10 minus 1. So again because it will be 10, so 10 minus 1, it's 1. Now this is 0, and 0 minus 0 will become 1, 0, and 1 minus 0, it will be 1. So answer will be 1 0 1 1. Okay, let's do bigger digits, like suppose 1 1 and 0 0 0, again 0 0 1 1. Okay, now 1 0 1 1, again 1 1 and 0 0. Suppose this is the last example of subtraction, example number 6. Now 1 minus 0, it will become 1. Again 1 minus 0, it will be again 1. Now there is 0, so we have to borrowing from the previous columns. So borrowing from this column to this next, to next, and to next. So it will become 10, and 10 minus 1 will be 1. Now this is 1, it will be 1, it will be 1, and it will be 1. So 1 minus 1 will become 0, 1 minus 1, 0, 1 minus 1, 0, and 1 minus 0, it will become 1. Now this is 0, and borrowing from this, then it will become 10. So 10 minus 1, it will become 1, and this is already 0. So answer will be 0 1 1 0 0 0 1 1 1 is the final answer. So this is the basic of the binary subtraction. Now the third arithmetic operation is the multiplication. So how to multiply two binary numbers? So the binary subtraction. Okay, the basic rule is the 1 into 1, it will become 1, and 1 into 0, it will become 0. Simple. Now, so the binary subtraction, binary subtraction, not binary subtraction, it's a multiplication, no, sorry. Okay, so binary multiplication is the easiest operation. Because the basically, if you understand the addition and subtraction, then it will become very easy to multiply the binary numbers. Now suppose there is a number 1 1 0 and 1, and multiply by the suppose 1 into 1. Okay, now just multiply numbers, because there is the only two operation which is very easy to multiply two numbers. So first take this number, which is the rightmost number. Now 1 into 1, it will become 1. 1 into 0, it will become 0. 1 into 1, again 1. 1 into 1, again 1. Okay, now the next number is again 1. So 1 into 1, it will become 1. 1 into 0, 0. 1 into 1, 1. 1 into 1, it will be 1. Now the next thing is the addition of this resultant number, because in the binary multiplication we have to do multiply, then we have to do the addition. Okay, so now 1 is 1. Now 0 plus 1, it will become 1. 1 plus 0, 1. And 1 plus 1, it will become 0 and carry to the next column. Now 1 plus 1, it will become 1 0. So 1 0 0 1 1 1 is the answer, or multiplication of the 1 1 0 1 into 1 1. Is it clear? So basically the binary multiplication is the very easy process or easy operation. Okay, suppose we have the second example, like 1 into 1 in 1 1 1 1 and 1. Multiply these number into 1 1 1. Okay, now just take the rightmost number and multiply to the rightmost number. So 1 into 1, it will become 1. 1 into 1, it will again 1. 1 into 1, it's a 1. 1 into 1, it's again 1 1 1. So 1 1 1 1 1, 5 times ones. Now the next number is the again 5 type 1. So 1 1 1 1 and 1. The last one is again 1 1 1 1 and 1. Now just add these all ones and you will get the correct answer. So 1 is 1. 1 in 1 plus 1, it will become 0, and 1 will be the carry. Now 1 plus 1, okay. 1 plus 1, it will become 1 0. 1 0 plus 1. Okay, this is the basically challenging portion, because the addition is going to the in 3 digits. Now suppose 1 plus 1, it will become 1 0. Okay, and 1 0 plus 1, 1 0 plus 1, it will become 1 1, and 1 1 plus 1, it will become 100. Okay, so basically it's a 0 and the carry will be 1 0. Okay, so carry will be 1 0. Now The 1 0 plus 1, it will become 1 1, and 1 1 plus 1, it will become 1 0 0, 1 0 0. Now 1 0 0 plus 1, so 1 0 0 plus 1, it will become 1 0 1. Now 1 is here and carry is again 10. So 1 0 plus 1, it will become 1 1, 1 1 plus 1, it will become 1 0 0, and 1 0 0 plus 1, it will become 1 0 1. So 1 is again and carry will be 10. Now 10 plus 1 or 1 0 plus 1, it will become 1 1, 1 1 plus 1, it will become 1 0 0. So 0 and 10 is again carry. So 1 0 plus 1, it will become 1 1. So answer will be 1 1 0 1 plus 1. 1 1 0 1 1 0 0 1. This is the final answer of the multiplication. Okay, so always remember the most important thing is the operations. Okay, so this is the most important operation, and follow this operation, because if you mistake to add the numbers or add the binary numbers, then the answer will be wrong. Okay, so always remember what will be the answer of adding the 100 and 0, it will be 101. So if you want to add 101 plus 1, then it will become 110. So similarly, this is the most important operation, because if you do any mistake in this portion, then you will get the wrong answer. Okay, so this is the most important part, or you will you can say that the basic binary arithmetic depends on these operations. Okay, now so this is the basic arithmetic operation of the addition, subtraction and multiplication. Now the next operation is the binary division. Okay, binary division. So binary division, the basic operation in the division is just 1 divided by 1, it will be become 0. Okay, similarly, if you the basic thing is just remember 1 divided by 1, that is the 1. Now suppose if you want to divide 11 by the 10, okay, simple. So the 10 is the divisor and 11 is the dividend. So now just divide or multiply any binary numbers, then it will become the less than the 11. So it will goes to the just in one time. So 10 1 ja, it will become 10. So now the addition or subtraction will be in the form of the binary. So 1 minus 0, it will become 1. Okay, so 1 and minus 1, it will become 0. Now the 1 is less than 10, then it's not possible to going to next division. So the answer or quotient will be 1. Okay, and the remainder will be 0 1 or 1. Okay, now similarly, if you want to divide 110 by the 11, then it will become 1 time. So 11 1 ja 11. Now 1 minus 1, it will become 0. 1 minus 1, it will become 0. The next one, the next digit is the 0. So it will goes to the 0 time. So 0 0, and the answer will be 1 0. So the basic the division is belongs to the basically our decimal methods. So it's a very easy to divide any number. Suppose the examples are, the first example is suppose 1011101 divided by 11. Okay, now the 101101 is the dividend and the 1 is the divisor. Okay, now 101101 divided by 1 1. Now the first portion of the this number you can put together 1 0. So this is suppose Okay, let's assume the example is like 1 0 1 0 1 0. Okay, 1 0 1 0 1 0 and divided by 1 1 0. So now the 1 1 0, you can see that if you take the single numbers, then taken the leftmost number, which is the 1. Now 1 is less than 110, so that's why it will goes to just 0 time. So it will be 0. Okay, okay, 0. So 0, 1 minus 0, it will become 1. Now take this number, the second digit, which is the 0. Now again 10 is less than 110, so that's why it's a 0 time. So 0 0, the it will become 0 minus 0, and 1 minus 0, it will become 1. Now the next number is the 1, so it's a 1. Now 101 is again less than 110, so that's why it's go again the 0 times. So 0 0 and 0, the subtraction is the 1 minus 0, it will become 1. So 0 minus 0 and 0, 1 minus 0 is the 1. Okay, so 101. Now the next digit is the 0. So it's a 1010. Now you can the 1010 is the 4-digit number. Basically this is the greater than 110, so that's why you can do one time or and write down in the left rightmost side, so it will become 1 1 and 0. Okay, so it's 0 minus 0, so 0, 1 minus 1, it will become 0, and this is borrowing from the previous column, so it will become 10 or 10. So 10 minus 1, it will become 1. So the 100 is less than, again less than 110, and the next digit will be 1. So the dividend will be 1001 and divisor is the 1110. So the 1001 is the greater than 1110. So that's why again you can do in the one time. So 1 ja, it's again 1 1 and 0. So 1 minus 0, it will become 1. Borrowing from the previous column, so it will become 1 and it will become 10. So 10 minus, it will become again 1, and 1 minus 1 0, so it's again 0. Okay, the last digit is the 0, so the dividend will be 00110. So the 110 and 110, which is equivalent, so last time it will be one time, so 110. So the final remainder will be 0, and the answer will be 0 1 0 0 1 0 0 0 1 1 1. So basically you can neglect this 0 and the final answer will be 1 1 1. So this is the basic procedure of the division or binary division. Okay, now let's do another example. The example is 101101 divided by 101. Okay, 101. So the procedure will be the similar, 101101 divided by 101. Now you can directly use the 101 for the 3 digits number, so it will become 1, and so 1 times, so 101, it will become 101. So the subtraction will be 1 minus 1, it will become 0, again 0, 1 minus 1 0. Okay, so now you will get the one number. Okay, the number will be, our dividend will be 0001, which is much less than the 101. So that's why you are going to next step. So the second number will be here, or put down the 0. So add the 0 on the quotient portion. Again, the 10 is less than 101, so that's why you can directly use the next digit, which is 1, and again add the 10 in the quotient portion. Now the dividend will be 101 and the divisor will be 101, so it will become the equivalent. So 101 is the 000 will remainder. Now the answer will be 1001. That is the final quotient of the 101101 divided by 101. Okay. Okay. So this is the answer. Similarly, if you want to divide 110 and 11 and divided by 11. Okay. So you can take the two digits 1 so it will become 1 time. So 11 1 1 that means 11. Okay, so always remember, in the binary operation, it's not called 11 10 or like this. Always these are called the 1 1 or 1 0 type. Okay, so now 1 minus 1 1 it will become 0, and 1 minus 1 it will become again 0. Now the next digit will be 0, which is not possible to divided by the 11. So that's why again you can take the next digits. This is the 1 and add the again 1. Again the next digit will be 1 and add 1 0. Now 11 and 11 will be equivalent for the 1 time. So 1 1 and it's a 0 and 0. So answer will be 1001. Okay, so this is the binary divisions. Okay, I hope you all understand what is the procedure of the binary divisions. Okay, so addition, subtraction, multiplication, and division, these are the four basic operation, arithmetic operation for the binary number systems. Now the second topic is next topic is the number system, and the last one is the basically the converting the number system or convert the one number system to the another number system. So the converting from one number system to another number system, basically these operation will be, if you want to convert the decimal to binary, then you can convert decimal to octal, decimal to hexadecimal, and binary to decimal. Similarly, octal to decimal and hexadecimal to decimal. So basically the two most important, or you can categorize into two most important conversion. First one is the decimal to any other number system, and second one is the any other number system, any number system to the decimal. Okay, so decimal to any other number system, that means decimal to binary, decimal to octal, decimal to hexadecimal. And the second portion is the any number system to decimal, that means binary to decimal, octal to decimal, and hexadecimal to decimal number. Okay, this is the converging operations. Now okay, the first thing is the first operation or first conversion process, that is the decimal to binary. Decimal to binary conversion. Okay, decimal to binary conversion. Suppose if you want to convert, the example number first is 27, which is basically a decimal number. If you want to convert this 27 into the binary, so the base of the binary number, which is the 2, and the base of the decimal number, which is 10. Okay, now if you want to convert the any decimal number to the any binary number, then you have to follow the basic rule, which is the division method. So write down 27. Okay, divide this 27 by 2. Okay, so it will be 2 1 ja and 2 3 ja. So the remainder will be, write down in the next column, that will be the remainder will be 1. Okay, because 2 1 ja, it's completely divisible. Now the 2 divided by 7 divided by 2, it will become 3 times. 2 3 ja 6. Now the 1 is the remainder which will be written in the next column. Now the next step is the again divide 2, 13 divided by 2. So 2 6 ja, it will be 12. Now again there is a 1 remainder, that is the 1. Now the next step is the 2 3 ja, it will become 6. Now there is no remainder, so the remainder will be 0. Similarly, again divided by 2, so 2 1 ja 2, there is 1 remainder, that is 1. Okay, now the last one is the 2 0. Okay, so 2 0 and the remainder will be 1. Okay, or you can ignore this step. This last step will be ignorable. You can directly use these number because there is no chance to divide 1 divided by 2. So that's why you can skip this step. Okay, now what will be the answer? So the answer will be, I also always write down these binary numbers from this order. Okay, so the first number will be 1 and the last number will be 1. Okay, so answer will be 1. The next number is 1. The next number will be 0. Again, the next number will be 1. And the last number will be 1. Okay, so this is the conversion of the 27, which is decimal number, and 11011 is the binary number. Okay, so the both number are equivalent to each other, but this is the form in the binary and the 27 is the in the form of the decimal. Okay, so is it clear? Now suppose the next example is the number is 129, which is the decimal number, convert to convert the in the binary number. Okay, so again you can follow the same procedure, 129 and divided by 2. Always remember divided by the base number of the number system. So the binary number system's base number is the 2, so that's why we have to divide it by 2. Now the 2 6 ja, it will be 12, and 2 4 ja, it will be 8. There is one remainder, so 1. Now the next again divided by 2, it will be 3 times, and this 2 times. Now there is no remainder, so 0. Again 2 1 ja and this 12, so 6 ja, so no remainder, 0. 2 8 ja, there is no remainder. Now 2 4 ja, again 0, and 2 2 ja, it's a 0, and last will be 2 1 ja, there is again 0. Now the answer will be write down from the this order. Again 1 0 0 0 0 0 0. So 6 times 0, then last number is the 1. So this is the binary number. 1 0 0 0 0 0 0 1 is the binary form of the 129. Okay, the next example is suppose 84. 84 is the decimal number which I have to convert it into the binary system. Now 84 divided by 2, it will become 4, and 2, there is no remainder, 0. So again 2 time and 1 time, there is no remainder again. So 2 1 ja and 0, that means there is 1 is remainder. Now again 2 5 ja 10, there is no remainder, that is 0. So 2 2 ja 4, and again 1 remainder. Last one is the 2 1 ja 2, and there is no remainder. The answer will be 1, and the second number is the 0. third one is the 1, again 0 and 1, and last one is the last is the 0 and 0. So this is the binary form of the 84, which is binary number 1010100. Okay, so that's it for today. There is some more operations or conversion operations we will do in the next class. So the next class will be the last class of the theory portion of the syllabus, and then we can do some MCQs practice of the all the topics of the syllabus. Okay, so the next class will be the last class of the our theory portion of the class. Okay.
To watch the complete video, download Mining Gyan 2.0 app from the Play Store and enjoy seamless learning with Mining Gyan 2.0.